All right, we are going to discuss sinusoidal curve fitting, how to get a sine curve of best fit for our sine function. So, looking at the textbook, this is number 29 on page 170, and I have this table inserted onto Desmos.com, and so that's number 29. It's the average monthly temperature for the months of a year for Alaska, for Juneau, Alaska. Month 1 would be January, month 12 would be December, and then the average monthly temperatures are given right here. We're going to create a sine, an equation of a sine graph that would best fit this data right here. So let's start by getting the sine function y equals the sine of x. And if you notice, it's way down here where we would expect it, but our values are up here. So we need to get this sine graph to match this um, this set of data here. So first thing I'm going to do is I'm going to restrict the domain so I don't see all this extra stuff. I'm just going to see from 0 to 12 because that's our value of x's, from 0 to 12 or 1 to 12. So you restrict the domain on this website by opening a bracket and say that 0 is less than or equal to x, which is less than or equal to 12. All right, so here we have this sine function on the given domain, and we need to make this match that. So the first thing I like to do is to figure out where the midline is. I obviously need to see that this graph needs to be shifted up, so the midline is right about here. So I find the midline by taking the highest number minus the lowest number and figuring out what's right between them. Okay, so highest number minus the lowest number, well, that would be the highest number looks like it's for July, so that's 56.0. 56.0 minus the lowest number is January, so 56 minus 24.2 is 31.8. 31.8. And then in order to find the midline, we need a, so the distance from here to here is 31.8. So to find the middle point between that, you just divide 31.8 by 2, and you get 15.9. So divide that by 2, get 15.9, and then add the 15.9 to the lowest number, or subtract it from the highest number. So in essence, you're just trying to figure out the middle, and it looks like it's going to be somewhere around 40. So I'll add the 15.9 to my lowest number of 24.2 and get uh, 31.8. Now, hold on one second. Um, 40.1 is the midline. All right, so on the end of here, I need to add 40.1. And like I said, it was right near 40, 40.1. So this is, it changes the midline from the x-axis to being right here. So now we need to, the next thing I see is we need to stretch it out so that way it has a higher amplitude. So we do that by kind of doing the same thing as we did for the midline, taking the high minus the low. And the high minus the low, we already did that in math before, I believe was 30.1, but let's just do it again. It's 56 minus 24.2, and that's 31.8. So from the top to the bottom, it's 31.8. So that means from the top of the wave to the bottom wave is 31.8. In order to figure out the amplitude, we have to cut that in half. So cut that in half, and we get the 15.9. So the 15.9 is going to go out front here. 15.9, and it looks like we're getting closer now. Now, the next thing we need to do is realize that from here to here is one period. So we need to, but it looks like so far we have a period of, we have one, almost two whole periods happening here. So we need to figure out the number that goes in front of the x, omega, for the period. And here's how we're going to do that. We're going to remember that that the period is equal to um, 2 pi over omega. Well, if our period is 12 because there's 12 months, then we get 12 equals 2 pi over omega. If you cross multiply, you get that 12 omega equals 2 pi. Thus, and then you divide by 12, and you get that omega is equal to pi over 6. So over here, let me go back to that. So over here on our, in front of the x is where omega goes. We're going to put pi over 6. So we'll say pi over, oh, hold on, that didn't work. Let's go back and let's open up some parentheses here. Let's say pi over 6. Okay, but we also want to close those parentheses right there. Okay, so pi over 6. We're also going to need a phase shift. So let's open up another set of parentheses here. And we're going to need a phase shift of, let's see here, this is not how it should look. 5 or 6 times, maybe it is. Well, we need to move this peak over here. So it's currently at 3. We need it to be at 7 because that's July. So we need to move it 4 to the right, which means on this x we need to do a minus 4. And that didn't quite work. So let's see here. This pi over 6. Okay, this parenthesis right here needs to be like that. There we go. So that's how it should look for your notation. Okay, so y equals 15.9 sine of, and then open parentheses pi over 6, and then open parentheses again, x minus 4, double close parentheses plus 40.1. And I just have the domain restricted there from 0 to 12. And that is how you do it.